Welcome to goonlinetrainings.com. So yesterday we spoken about how to create a staging. Staging is similar to OLTP database only, but only the difference is that we always truncate the data and we are going to be loading the data. When the data is reached staging, from here to here, if you wanted to load, we are going to be implementing incremental loading. What is incremental loading? That you're going to be learning as part of SSIS. That is going to start from the next week. Okay, probably Monday or Tuesday we'll start SSIS. Okay, so now first you need to create a blank data warehouse because staging is very simple. It is a replica of OLTP database, but it's a blank database. Correct? So now I have to design a data warehousing database. If you wanted to design a data warehousing database, let us see what are the things that we're going to be implementing. This is my OLTP database called Amazon. I have a table called product master table. I have a table called category master table. So what are the categories? Soaps and detergents, food and beverages, furniture, stationery. So in the product table, I have one pen price is, 40 rupees or 40 bucks and it is belong to 40 category. 40 is stationery. అర్థమవుతుందా? So like that, we have a Coca-Cola belong to 20. 20 means food and beverages category. So these are two the OLTP tables that we have. There is a customer master. So these people have registered John, Peter, Lakshmi, Bhaskar, Leela from different cities and different phone numbers, and they have complete address, right? So this is one more table is created. Now there is a sales table, customer ID 102 Peter and product ID 2. So what is that? He purchased 2 pencil and date of sales is 21st of October 2016 and 1000 products sold, and this is the amount he paid, and 21st he order and a 23rd date of delivery is happened, then payment mode, currency, lot of other things are available. So okay, so delivery is happened after say 2 days of the purchase, clear? So that is the data I have it. Now I wanted to create what is called as a data warehousing for this. Now we are going to be creating a staging, right? So we need to create a staging database. Let me insert one workbook here. So let me have this is what is called a staging. So stage database. So what is the database name? So let me take same database we're going to be having. It is not a normal database, it is stage database, Amazon stage. Now the database, the table name is called stage or stage underscore. You will be able to have the primary keys and foreign keys will not be there, but you will have the same columns. This is a stage database. Clear? So database is stage and Amazon. One table will be like this. Second table, you will have a category master. So I'll have the same table here. I have a same table there. So I'm going to be creating with the same column names and everything. Now you will be able to have the same columns, but primary key will not be there. And you are going to be prefixing or suffixing whatever you want to have it. Stage underscore category master or category stage, something like that. We are going to be creating a blank tables. Okay, blank tables, not the with the date. So we delete and we name and we create these tables. So this is what is already done, right? Now the next table is called as this table. Now date of delivery and the data we are going to load. So this is a normal table. So no foreign keys, nothing. We simply create a blank tables and we load the data. How do you load the data? With the help of SSIS package. You should know how to load the data. So this is a blank database we must create. So using the staging, we create data warehousing database. Correct? So if you wanted to create a data warehousing database, The product stage master database will be converted as dim product. Clear? So the conversion has to now will happen, right? Now let me go back. You have OLTP. From OLTP to we have a created stage. We have a stage category master, and we have a stage product master, and we have a stage customer master, and we have a stage sales table, right? So when you want to create a data warehouse, the first table I'm going to be creating dim product master. The first table I'm going to be creating this dim product master table. If you observe carefully, the naming conventions are changed. So uh, you have the product ID here, but it has become a product key. In this, you have a name. It has become a product name. So like that, so you will be able to get the changes. Price will become product price. And if you observe carefully, category ID is there, right? So category ID we're getting from here. So how you're going to be getting category ID? So when you go to this, you will be able to get category ID 40 and 40, you get it, and you will be able to get the stationery. So in that, I'm directly keeping the category name. I don't have any, I don't have any category ID. And one more thing, this table is also not there. This table is completely removed. Clear? So if you observe carefully, I wanted to have product ID, product name, product price as it is. Now what we have done in the OLTP, we have created one more table called category master. We have given a number. This number we are storing. 10 means what? 10 means little soap, soaps and detergents. So in the data warehousing, what I have done, I don't want to create this table with this data. I don't want to keep the category ID here. And instead of category ID, instead of a 40, what is 40? Stationery. I wanted to write stationery and remove this column, remove this table. So that is what I have done. I don't have a dim category table. So that is one thing I have done it. Clear? In OLTP, I have two tables, product master, category master. I have a foreign key here. I have a primary key here. So I am linking like this. But in a staging also, there are two tables. You will be able to get the data in the data warehousing. What I have done, I did not include category table at all. Category data, I have used it here. So what is the reason why we need to create in the data warehousing? Okay, yesterday I told you one point. What is the point? So if you wanted to create a best data warehouse means, first point I told you, you have to study existing OLTP system. Kada OLTP and its tables మీరు స్టడీ చేయాలి. సో ఎగ్జిస్టింగ్ OLTP and its tables అని చెప్పుకున్నాం. రెండోది, you have to study existing reports, whatever be the reports that currently preparing, okay, and KPIs that they're using, or the dashboards that are preparing. So they're using all these things also you should know. Okay, ilan dashboards unnaya, ilant reports unnaya all data మీద. The next one, you have to also study future requirements. Okay, so this kind of what kind of a future reports they would like to have it. So future requirements ante what kind of a future reports they would like to have it, dashboards or future KPIs, what kind of a metrics they wanted to have it. All of the future requirements also make తెలియాలి. So if you wanted to create a data warehouse, that is also one more point. One more important point you should know, to create a best data warehouse, you have to reduce number of dimension tables. ఇది కూడా ఇంకొక పాయింట్. Okay. For example, in OLTP, let us say we have 1,000 tables అనుకుందాం. 1,000 master tables, and let us say some 30 you have transactional tables. Clear? So that is what OLTP is having. In the data warehousing, you should not keep 1,000 those master tables as a dimension table. You should not arrange, okay, again same these, these tables. This is not the way. This is not the right, the makki ki makki translation is bad. So what we are going to do, you have some data in the 1,000 tables. Clear? So according to the data warehousing concept, reduce number of dimension tables. అంటే అర్థం ఏంటి? 1,000 టేబుల్లో ఉన్నటువంటి డేటాని you arrange them at least into some 600 tables, something like that, or some 645 tables, right? Some tables, but definitely you have to reduce the number of tables. Data అంతా అదే ఉంటుంది, but data will get added. For example, you wanted to go to Vishakhapatnam or you wanted to go to Dubai today. You have 3 luggages, but we know when you have more luggage, it is bad. More luggage is always bad for the the traveling. So what we 3 luggages, luggages will be kept into 2 luggages. So end of the day, same items are there, but number of luggages are going to be reduced. Clear? So that is the point whenever you go anywhere. So what I wanted to keep only all the data, but adjust them in the 2 luggages, not in the 3 luggages or 4 luggages. So reduce the number of suitcases while traveling. The same technique is used in the data warehousing also. Even though you have 1,000 master tables in OLTP, but all the data you have to organize them in the organize them in the less number of tables. So the problem is that if you have more and more tables, you will have more and more joins. So a lot of issues are going to come. So OLTP will have more tables always. Remember this. OLTP will have more tables. This concept is called as a normalization. అర్థమవుతుందా? So OLAP or data warehousing will have less tables. This concept is called as a denormalization. Okay? Two things you have to understand clearly. What is a normalization and what is a denormalization? Give me just 1 minute of time. I'm getting some. Sorry, guys. Okay. Now, there is a concept called normalization and denormalization. Why? In OLTP, we have to create 2 tables because OLTP recommends more tables. OLAP recommends less tables. This is the concept. Okay. Creating more luggage. You have taking 3 baggages is called as a normalization. But a 3 baggages, 3 bag luggage dump into 2 baggages is called as a denormalization. అర్థమవుతుందా? Let us understand what is the difference between this and why we need to create. Clear? So now let us say I have some data. I will create a employee table. So employee ID, employee name, employee salary, and we create a department ID. Kada? So we will also create one more department table and we'll have department ID and department name. So department ID is a primary key, sales department 20, accounts department. So like that, we are going to be preparing a beautiful table like this. Okay. Let me take this and let me keep it there. Okay. I have a department table. So this is my data. Department ID is a primary key. Now I have a sales, I have a 30 R&D department and 40 mechanical department. Clear? I have created some departments in OLTP. This is OLTP database design. So this is my table. Now this is my primary key and this is my foreign key. So first employee is going to be joining. Let us say Naveen is going to join in our company. Clear? So Naveen Majji is going to join. Salary is $10,000 and he is working for, let us say, R&D department. I'm going to be rating 30. Now, one more guy, let us say Lakshman is going to joining with 20,000 salary and is working for department number 10. 10 is called sales department. Like that, we have three people and one more guy called Girish or Hemant is going for 12,000 and is going, working for 30 department. And the fourth, see, let us say Girish is working for, same department as a 30. And we have one more guy called, John is also working for $7,000 working for this department. Like that, I have some data. Now, this is my design. This is my design. So what is the department number 30? R&D. So one guy told me, Bhaskar sir, you don't have any knowledge. Why are you creating two tables? This is not the good idea, sir. I will create one more beautiful table. One more guy is preparing a table design like this. So instead of a department name, what is trying to keep department instead of department ID, he is writing department name as it is here. అర్థమవుతుందా? So he is going to be preparing like this. 30 department is R&D, right? So R&D is writing directly here. And 10 department is sales, is going to be writing directly here. And 30 department against R&D is going to be writing something like this. Okay. So he says, why are you creating two tables? It is nonsense. You don't know any knowledge. So let me create one table. I'm able to, do whatever you have created. The same thing I have achieved. Instead of creating a primary key, blah, blah, blah. So I'm going to be creating this. This is what is the best design. Both of them are perfectly fine. But if you intelligently understand this design is good, then this design. But in OLTP, this design is good. Only in the data warehousing, this design is good. So this design is bad. This design is bad in the OLTP. Let us understand why this design is bad in OLTP. Why OLTP databases will create more and more tables. Two tables data merged into single table is called as a denormalization, right? So one table data got split into two tables is called as a normalization. Let us understand why we have to create like that. It's very, very interesting, important point. Clear? In OLTP, if you understand, OLTP is a database. Kada? Overlap means data warehousing. There is also one more database. Kada? So both of them are databases only. Why we are going to create like that? Let us understand one by one. Okay, very, very important point. Please concentrate clearly on this topic. Okay, very, very important, guys. Okay, na? So in OLTP, as we understood the day one, OLTP always will have read and write data, or you can say it is going to be having a fresh data. అలాగే so most of the time we are going to be writing the data. I told you 80% of the time this database is busy getting the data. So customers are going to the bank and transferring the funds, depositing the cash, withdraw the cash. Lot of time the deposits are more. Once in a while you check what is my balance. That is so 80 to 90% of the time in many OLTP applications, data writing is going to happen. So you go to the Amazon, you're going to be buying the product, right? Many people are buying and many people are also viewing. So more viewing, writing is more, because Amazon will not get a profit only if you view the Amazon and leave it. So they're getting more and more profits. Means what is the meaning? They are, the sales is also more. Sales is means writing is more. When the writing is more, you have to have a normalization technique. What is a normalization technique? Create more tables. Okay, you should not have less tables. If I create more tables, what is the advantage? I'll tell you. Okay, for example, in this I'm able to write. So writing means what? Writing means, according to writing means two things. Either insert the data or update the data or delete the data. So that is what is called writing. Reading means what? Reading means only selecting the data according to the RDBMS. Reading the data means select. Writing the data means insert, update, delete. So in the OLTP, we have more writing and argument. You are going to be inserting the data, updating the data, deleting the data, all these operations. For example, tomorrow I have some data, I'm inserting the data. When I insert data, for example, new employee joins it. This is OLTP. I'll create two tables. New employee joins tomorrow. How to insert data? I'll go here. 6. I rate name is called Amar, and let us say $5,000, and he is going to be working for, let us say, 20 department or 40 department. Now, if I, because this is compulsory, I need to write it. So here I'm going to be putting 40 instead of 40. Instead of 40, let me go and write the same thing here. So the same data is also, it goes. But instead of putting the number, you have to write the complete spelling. So you have to write MECHANICL. When you write like that, how much of time you're taking? Writing 40 is a very small number, very short number. It may take 1 second. But when you write a bigger spelling like that, so you may take 2 seconds extra, 3 more seconds extra. So if you're writing 10 million data, means 10 million seconds are extra. అర్థమవుతుందా? 10 million seconds means it is going to take lots of time to write the data. So when you create a single table, when you store the spelling here, instead of storing writing 40, writing the complete name will take a lot of time. You will take 10 million, inserting the data 10 million times, and 10 million 3 seconds are going to be extra. So 10 million times, every time 3 seconds extra, you are going to be slow when you create like this. So when you create a OLTP approach, so this will be faster. In the OLTP, it is very, very faster. Why it is very, very faster? Because instead of writing the complete mechanical, you are going to be simply putting 40. It is a bit faster. So rather than writing the complete data. So if you create a single table, you are slow. But in OLTP system, most of the time it is going to be writing the data. You should not take not even 1 extra millisecond. If you take 1 extra millisecond, when you have billions of transactions are going on, 50 billion into 1 second, it will be hours together. So you are going to be taking more time to write the data. So we never create this kind of a tables. Clear? That is for the insert. Let us say update. What is update? Tomorrow, the R&D department name changes. So it is a completely research. Okay. It is completely research that I wanted to write. Research and development. Okay. I'm writing the complete spelling only once. What I'm done, I'm updating the data. When I update the data, now I have updated only once. So wherever 30, it is going to be getting the same spelling. But what about here? So I have to update here. If I update here, is it done? You have to update here as well. You have to update here as well. you have to update here as well. So updation is when you do one time, wherever there is a 30, the latest spelling you are able to get it. So one time update is done. But here, when you store the data, if you do only one update, remaining spellings are not changed. So you need to go to each and every row. You have to update. So updates also very, very faster. అర్థమవుతుందా? When you create a two tables, if you update once the data in the second table, automatically it is very, very fast. If I wanted to delete some data, so delete also very, very fast. How delete is very, very faster? For example, I go uh, delete an employee where the department ID equals to 10. Okay, so it is very faster. Delete employee where a department name equals to research and development. So I need to find out whether it is a proper name or not. So I need to match that where clause and go reading and matching and deleting will take a lot of time, because which is a very, very small number. I can say where department ID equals to 40, can easily identify 40 only two letters it has to read. It has to read 100 letters or 50 letters and match it, then it has to read. So delete is also very, very slow. Clear? So when you split the data like this, when you split the data, always writing speed is very, very good. So most of the time we're going to be writing the data. So always when you create a two tables, so insert, update, delete will be faster. Clear? So that is advantage, because most of the time we are writing the data, it has to be faster. Clear? So that is what. But here, when you take this, into the data warehousing, so data warehousing, normally what we do, we never create a fresh data here. We will have historical data. అర్థమవుతుందా? Historical data, you never have this data, never have read and write. Once in a while we put the data. Most of the time it is read only data. It is denormalization concept. Okay, so here we are going to be using less tables. So this is the denormalization. Why it is good, why it is bad, let us understand now. Oh, okay, now everything is good. I wanted to read the data. For example, I wanted to know employee name, employee ID, name, salary. Along with the salary, I wanted to have a department name to be displayed. I have to join this table and this table based on this one to this one and get the data and the slow. So if you have more and more tables, you have to join. Whenever you join the data, get the data, it will become slow. అర్థమవుతుందా? Why the reading is slow here? Because you have many tables. Many tables means many joins. Join is not a very simple operation. Many joins. Because of many joins, the reading data from multiple tables is always slow. You have to join the data, get the data, give the data. Because it is okay, because 20% of the time only we are reading the data. Even though it is slow, it is fine, no problem for us. I have to concentrate only on the writing. So I create this kind of a tables. Now 20% of the time only I join the data and I get this, so that it chalega, no problem. But here, once in a while you load the data, you are going to be loading every 1 month, every 6 months, every 1 year. So out of 6 months, one day you load the data. Loading and అర్థం ఏంటి? Writing. Okay, remaining time you are going to be reading the data, reading and reading. Remember this. So one day, in a 12 months of time, you will have 364 days. You are going to be reading the data. Only one day you're writing the data. అర్థమవుతుందా లేదా? సో మోస్ట్ ఆఫ్ ద టైమ్ యూఆర్ రీడింగ్ ద డేటా. సో ఓన్లీ వన్స్ ఇన్ ఏ వైల్ 10% of the time you're writing, 90% of the time you're reading the data. So you should not create this kind of an architecture. So what we need to do, we have to get the data and keep it here. Right? What is advantage? Advantage, I wanted to know what is the employee ID, employee name, employee salary, along with the department name. So all the data is available in a single table. I need not have a join. Clear? So when you have lesser tables, so what is not required? So when you have writing and reading, writing will be slow. Writing means what? Insert. Insert will be slow here. And update will be slow here. Okay. Update will be slow here. And delete also will be slow here. That is fine because once in a 6 months, once in a 1 year, once in a week, I upload. But remaining time, I'm going to be only the data. Clear? So I am okay. I am slow for 1 day. That is fine. But remaining 99% of the time, I wanted to read the data. I don't want to do this kind of a joints and everything. So I take two tables data, bring into single table. So I wanted to read the data means less, tables I need to have it. When we have less tables, less joins are going to come. When the less joins are there, speed is more. Okay, speed is more. So when you have a denormalization అర్థం ఏంటి? రెండు టేబుల్ డేటా, much more tables data bring into one or a few tables. You have 1,000 tables data means 1,000 joins, but 1,000 tables data got into 500 tables means 500 joins. Clear? So the number of tables are reduced means number of joins are reduced. When the number of joins are reduced, speed is more for reading. అర్థమవుతుందా? Why denormalization means to increase the reading capability. Why normalization means storing the data into multiple tables, right? So why normalization means to increase the writing capability. Here writing speed is more. అర్థమవుతుందా? Speed is more while writing the data. That is what is the important. Clear? So according to the theory, normalization means removing the redundancy. That is not a proper thing. So according to the IT industry, normalization means storing the data in multiple tables. Automatically the duplicates and everything will get removed. That is fine. But why normalization is important? Normalization means storing the data in multiple tables. When you store the multiple tables data, your insert, update, deletes are faster, but reading is slow. So even though reading is slow, I don't mind because 80% of the time I'm going to be writing the data. So OLTP databases will be created always a not one table architecture. You will have a much more tables. OLTP will have more tables. OLAP database will have less tables because I wanted to concentrate on much more time onto the onto what? Much more time on the read only. So even though writing is once in a while, I'm going to be writing the data, much more time I have to read. So if I wanted to read, the first thing is that I have to reduce the number of tables. If I reduce it, I will get less joins. Less joins means the reading is faster. అర్థమవుతుందా? So denormalization means converting many tables data into few tables. Normalization means one table data split into two tables, three tables. I will give you simple example. When I was a bachelor, I have a single room. In the single room, I have a bed, I have a laptop table, I have a TV, I have a shoe, I have everything in the single room. So my friend calls me. Naveen comes and tells me, "Hey Bhaskar, let us come out, let us go for a movie." So I have everything in my room. I have a shoe, I have a dress, I have a laptop, I have a purse, I have wallet. Everything is available in that room. I can be ready within 5 minutes. Clear? But after I got a job, I purchased, let us say, some 3 BHK. Not only one thing, villa I have purchased. Clear? Let us see the problem now. Some items are available in the ground floor, bedroom. My wallet is available here. My shoe is available here. My belt is available in the first floor bedroom. Clear? My specs and laptop, I am working on the terrace, so I kept something over there. So if I want to get everything, I have to go to first bedroom, go to the second bedroom, go to the third place, get the saman here, get ready. It will take a lot of time. Clear? When you store the data in different tables, joining will take a lot of time. So when you keep all the data in a single table, that is what is called denormalization. Clear? Denormalization is always faster if you wanted to read the data. Normalization is always faster when you wanted to write the data. OLTP will have a normalization. OLAP will have a denormalization. That is the reason why OLTP has two tables like this, and this table I did not include in my data warehousing, so I have only kept this. So one table got reduced. Clear? Like that, when you have much more tables, the number of tables automatically will get reduced in your data warehousing. You will be able to create a denormalized architecture. What is the rule? Reduce the number of dimension tables in the OLAP or in the data warehousing. Why? You have to reduce number of joins. If you reduce number of joins, what is faster? Reading is faster. Denormalization will include more space. For example, storing 40, 40, 40 is good. Storing in a bigger spelling will take more space. So denormalization will take more space also. But even though space is more, chalega, because hard disk is today $100, 1 terabyte of hard disk. Nobody is worried about the space now. So all the data has to be retrieved within fraction of seconds, because data warehousing is going to be having tons and tons of data. If you create a lot of tables and lot of joins, it will become slow. Then tomorrow, the report viewer, the end user will come. BI is very slow. I hate this BI solution. Data warehouse is not at all responding. I hate. He will be telling every day the same story. Why? Because you have created 1,000 tables of OLTP, you have taken 1,000 tables of dimensions. That is where the problem comes. Because of this kind of issues only, the Kimball has become so popular. Right. So Inman says if you have ERD modeling, same ERD modeling you apply, ERD modeling is always creating a normalization. Remember that. ERD modeling always create a normalized tables. Normalized tables and echo tables. When you have more and more tables, and data warehouse will give you a lot of performance issues, because more tables, more joins. More joins, less read and the speed. So that is where the issue starts. That. So that is the point we have merged. So second table, I have a, this table is completely removed. One more table I would like to have, that is a customer table. So customer table, there is no change. I have taken as it is. So that is fine. The next table, I'm going to be having a sales table. And before that, I'm going to be including one more table. What is the table I'm going to be including? Dim location table. This table will not be there in your OLTP. OLTP will have a product, customer, and a customer will have a city like this. That's it. So they will have some address. But now in OLAP, we never do city-wise sales. So in your reporting, many times in your reporting, so you know what they will ask you? In your data analytics, they'll ask you, tell me country-wise sales, or they'll ask you state-wise sales, or they'll ask you city-wise sales. But you don't have any country, you don't have any state, you don't have any city in the OLTP. Do you have any country here? You don't have any city here. So you don't have. But in the reporting, they will be able to ask you, I need a country level, state level, this level, that level. But they may add the country here, or they don't have the country here. But how do I do that kind of a reporting? OLTP will not have that. And one more reporting they'll ask you, tell me year-wise sales, tell me semester-wise sales, right? Semester-wise, tell me quarter-wise sales, tell me month-wise sales, Tell me, week-wise sales. Tell me day-wise sales. Do we have separate data like this in OLTP? We have only one data of sales column. That's it. We don't have a quarter-wise sales, year-wise sales, month-wise sales, and you don't have any country-wise sales. You don't have this. But compulsorily, these are the compulsory tables that you have to plan. These tables are not available in your OLTP. So data warehousing will have all the dimension tables plus these two tables. So one table is called as a dim geography table. Compulsory table you have to create. Dim geography table. One more table you need to create. One more table is called a dim date table. In that you are going to be having this kind of a data. These tables are not going to be there in your OLTP system. Clear? Remember this point as well. Now, let me show you one data warehouse that I did not create. This data warehouse created by Microsoft. Clear? I'll show you AdventureWorks OLTP database. Okay, let me show you this. So you have a lot of tables. Whatever I'm teaching you, I'm showing you. This database is given by Microsoft, not by me. How many tables you have? 1, 2, 3, 4, 5, 6, 7. So total number of tables are many. Okay. So if you wanted to know total number of tables, so use AdventureWorks. Select star from, there is a query, sys.tables. This query will give you number of tables, right? You can say count star. So when you execute this, 72 tables are available. This is what is called OLTP database. Okay. Now, what is OLAP database? OLAP database also we will connect now. OLAP database name is called AdventureWorks DW. Let me count the number of tables here. Execute this query. 29 tables. Okay. So total 72 tables data organized into how many tables? 29 tables. That is step number 1. And I told you data warehouse should have 2 more tables. What are they? Dim geography, dim date. So this table may not be available in your OLTP. Have you seen any geography table here? In a table like this, you will have a region table, but a separate dim geography table will not be there. There is a dim date table, kind of a table also. You don't get it in the OLTP. But let me go to OLAP. OLAP means data warehousing. This is data warehousing. So you will have a dim geography. Have you seen this? There is a dim date table. Have you seen this? So every data warehouse will have these two tables. Why? Tomorrow, many customers will ask you country-wise sales, state-wise sales, city-wise sales, year-wise sales, month-wise. If you wanted to handle these two tables are must. So I have created two more tables. This table, so it is going to be having, let us assume that the sales is going on in India as well as in America. So I have to load a table, a location table, geography table, all the states and all countries from the India as well as all the states of America and all states and all cities of America. This table I need to create, I need to insert on my own. I am not able to get the data from OLTP. This is one table that you need to create. This is one table. A developer has to insert the data by Googling what are the countries in what are the countries and all the states available in the Google, get it and insert. This is the table that you have to create. This is one table. One more table you need to create that is called dim date or dim time table. So in that you have to include the full date column, year number, semester number, quarter number, month name, and week number, day name. Is it Ramzan day? Is it a holiday? A lot of things you need to include. But which data you would like to insert? Let me go to OLTP. The first sales is happened on the 21st October. Okay. So like that, the first day, whatever the sales is, whenever the business started, you will be able to get the sales date. So this date has to go here as the first date, and continuously we'll have continuous dates. So 20th, 22nd, 23rd, 24th, you will be able to give continuous numbers. So like that, next 10 years of data, you are going to be inserting continuously. So this is October month. Year number is this. Semester, October means semester 2. Quarter, it is October means quarter. Month number, October 10. October, this is the month name. And the week number, let us say this is week number 47, and a day number 21st, and a day name, let us say it is a Friday. So lot of things you need to have it clear. Now sometimes what will they ask you? I wanted to know, they will ask you this kind of a questions. Okay, so what is the sales in Ramadan month, or what is the sales in weekdays versus weekends? Okay, and what is the sales? This kind of a questions are going to be asked. Sorry guys. Okay, so they will ask you Ramadan, what is the sales in Ramadan? So do you know what is the Ramzan? So when the Ramzan in 2016, do you know? When the Ramzan in 2017, do you know? When is the Ramzan in 2018, do you know? So they will ask you what is the sales in the Diwali. Okay, Diwali sales they wanted to have for current Diwali, last year Diwali, because these dates will change. Current year Diwali November 7th, last year Diwali October 21st. So they wanted to understand the last year sales and current year sales, and Ramadan every year it is going to be changing. So if you wanted to analyze like that, you have to have one dim date table. In that, you have to have a column called is it Ramzan? Clear? Is it is it a holiday? Is it a weekend? So lots of things I am going to be writing. Day number, day name. So is it a weekday? Is it a Ramadan day? Or is it a Christmas day? Or is it a Diwali day? Or is it a Dasara day? Like that. So people would ask you, for example, this day comes under Ramzan day. Say yes, 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 yes. Next year, that the Diwali, the Ramzan may start in the month of say September. Clear? So that is what is the point. So if you wanted to have this kind of a questions, definitely you should be able to create a separate table called this. In this, for each and every continuous dates will be there. What is the starting date? Starting date always the business starting. The first transaction date will be the starting date here. Continuous numbers will be there. All the data manually you have to insert it. and you need to create one more table. So this is also one more table has to be created. Then you have one more table called fact sales table. So this table also we are going to be creating. So in the sales table, I have a customer ID, product ID, date of sales, quantity sold, and sales amount. These are the figures in the sales table. But in the fact sales table, lot of things will change now. So customer ID will become a customer key, fine. Product ID will become a product key, fine. But here we are going to be having a data of sales, which is a completely a date and time column. So in this, we don't have a data of sales. It is a completely integer column. So it is going to be having integer. So how you are going to be having this? Now you go to OLTP, you get the date 21st October. Now you go to the data warehousing. 21st October means date 1. So this 1 is going to be going here. Clear? So that is how the column names also will change. Now here it is a date and time. Now it is an integer value. Clear? So it is an integer value. This is sale date key. When the sales is happened on first. First means what this one? When the delivery is happened on the date of delivery, 23rd October. 23rd October means it is a third. So one, the sales is happened. This is the product and delivery is happened something like this. Clear? And we don't have any we don't have any location where the sales is happened, but the sales is happened to 102. 102 means what? Peter belong to Hyderabad. So this sales is happened to Hyderabad. I have to write the location also here. So the location is not available in this. The location is not available. I want to include location. So I kept location key here. So what normally we do, we take 102. 102 means this is 102. We get his city, Hyderabad. Now we'll get the Hyderabad city. We'll map Hyderabad here. So after mapping Hyderabad, we get the number called 6. The 6 number is going to be loaded here. So that this sales is happened to where? Hyderabad. Hyderabad is part of Telangana state. It is part of India. So tomorrow, if you wanted to analyze the data, you should be able to get the country level, state level, city level data. This column is not available in my OLTP, but I have included. So lot of things are going to change in your OLTP sales table to OLAP sales table. Clear? So you have to create one more database. In the database, you will have lot many new tables. Clear? So these are the things that you need to have it. So in data warehousing, you will have these tables: dim customer, dim product. You don't have the category dim date. Then you will have dim location or geography. Then you have a fact sales table. So you have to get the data from the source. You have to get the data from the source. This is manually you have to insert the data, manual data. So in this data, in this table also, we are going to be getting the data manually. This you need to load the data with the help of a SSS package. అర్థమవుతుంది. So you have to dump the data using SSS packages. In tomorrow's class, we will show you how to create SSS packages and how to dump the data from OLTP to staging first, because staging is always ready. Now you have to have the OLTP. The next one is staging. Then after the staging, we have to load the data with the help of SSIS here. OLTP to also this one we are going to be having. In the OLTP, I have a customer table, product table, sales table, category table. These two tables are not available in OLTP. Now this is how the data warehousing is going to be completely changing from OLTP to data warehouse. Compulsorily you should have a dim date table and dim like a location table. If you have 1,000 tables here, 1,000 master tables here, and if you have some 20 transactional tables here, so all of them will get reduced. Okay. In the data warehousing, you may have some 600 dimension tables plus two more tables you would like to have it. The two more tables are called dim location or dim geography or dim time. And you may have the same fact tables. Fact tables, we cannot reduce it. Okay. Fact tables, we will be able to have those fact tables, but you need to reduce the master tables into less number of dimension tables, because when you have a less number of dimension tables, less joins means reading is faster. Clear? Tomorrow I'll show you how to load the data, and you should know SSIS. If you don't know SSIS, so you can ignore tomorrow's class for one day. People who do not know, just watch. Okay. Later you can understand how the things are going to be happening. Ardhamavutunda? So that is what. Or I will give you one video. People who know SSIS packages, you load the data to the staging, and using the staging, you should be able to load the data into the data warehousing. When the data is loaded to the data warehousing, that means data warehouse is ready. Once the data warehouse is ready, what we need to do? Once data warehouse is ready, you have to create a SSAS cube. Clear? After that, you can prepare SSRS or Power BI reports. Clear? So tomorrow we'll load the data. So otherwise, I'll give you one extra video how to load the data from OLTP to the staging, from the staging to the data warehousing. Okay, so the one video I will upload. So all the people may not be able to understand. People who know MS SSIS, they can watch. Otherwise, that video you can just keep it as it is. So you don't want to watch the video because you don't understand how to load the data using SSIS. Clear? So once the data warehousing is ready, then if the data is ready, so then we need to know how to create a cube and all. So then we'll discuss few more points in the data warehousing. So after loading the data, we discuss about a lot of theory of data warehousing. We'll see it. Clear? So that is what is the tomorrow's class agenda. Any questions?